Welcome. I am waiting for Jen if she can. She's in Panama. They just had an earthquake, so she's dealing with some electricity issues down there, and she'll join us whenever she gets a chance. Today we're talking about the female immune system and how estrogen greatly impacts the woman's immune system. And when I was writing my course and putting everything together, over a decade ago and finally published 2018, I touched on this because there were some new studies coming out in 2014 as well as 2018 about how estrogen in females affects the immune system and its response to viral pathogens, bacteria, and all of this. And so that's in my course, but I wanted to get more in depth on it because as I was looking at some of the studies in my bibliography from that course, I was looking to see if I can update any of the studies, if there's any reviews or updates that have been done since then, and there have been a bunch. And so it took me down a rabbit hole a couple of weeks ago. We recently sent out a newsletter for BodhiBuilding. And if you're not on the BodhiBuilding newsletter, you can go check that out at BodhiBuildingInstitute.com. You can sign up for the newsletter. You can sign up for a free membership. You get all the information. So in this week's newsletter, it sort of culminated a summary, I guess you could say, a summary of everything I uncovered in my rabbit hole a couple of weeks ago. And we're going to really dig in deep with that now. So the immune system, we all have an immune system. We're finding out women, we have estrogen receptors or estrogen proteins, basically, that send signals to estrogen receptors, which are on every single cell in the body. And so we've got, we talk about immune health, as I shared in the newsletter. We talk about, taking supplements, getting enough sleep, managing your stress, detoxifying environmental chemical loads, things like that, because this will greatly impact how your immune system functions. And but now in today's day, we look at autoimmune diseases and how the prevalence of that has risen significantly in the past 20 years. But 85% of autoimmune diagnoses are female. So women represent 85% of autoimmune diseases and diagnoses, sometimes, in many cases, carrying more than one autoimmune diagnosis. And so we're learning that gender is not one of the main indicators of susceptibility to an autoimmune diagnosis. Although it plays a huge role, and I'll share why. So women have more estrogen than men. Men also have estrogen, but we've got three types of estrogen: E2, which is the main one we're going to talk about today, E1, which is estrone, and then we've got E3, which is estriol. So the predominant estrogen women carry that greatly impacts the immune system is estradiol, so E2. And that estrogen is in its peak and at its highest during reproductive years. And so when we look at autoimmune disease and its diagnoses on women, the average age is in reproductive years. Now, we do get a lot of autoimmune diseases are being diagnosed in children, unfortunately, at a quicker rate. But we do know common factors that do activate an autoimmune condition or disease. And those are environmental or chemicals, such as solvents, adjuvants. Viruses are known to activate the autoimmune condition. Poor diet is a huge leading factor because it leads to a lot of inflammation in the body, and more inflammation equals more disease. And then they have this out there, it's called the hygiene hypothesis. Now, this isn't mainstream, but it is well documented. The hygiene hypothesis is that nowadays we are more exposed to things like antiseptics, antibacterials, vaccines, and things like that, which leads to a lack of exposure to certain bacteria and viruses, which means the immune system can lead the immune system to overreact to certain pathogens, viruses, or other substances and things like that. And so we look at our peak estrogen years, again, 15 to 35, which is when most autoimmune conditions are diagnosed. The most common autoimmune diagnoses in women are alopecia, psoriasis, celiac disease, irritable bowel disease, type 2 autoimmune hepatitis, thyroid conditions such as Hashimoto's and Graves', Guillain-Barré syndrome, hemolytic anemia, and multiple sclerosis, rheumatoid arthritis, and lupus. And so these all then can be categorized into common age timelines of when we're diagnosed with these. And some are genetic or can be genetic, such as rheumatoid arthritis, multiple sclerosis, and lupus. These can be genetic as well. So speaking of which, our DNA, we have phenotype, genotype, karyotypes. Within each of our DNA, we're going to get chromosomes. We have these pairs, XX. XX means you're female, and within these chromosomes, we have estrogen receptor proteins. We've got two, and so we have double, right? And these estrogen receptor proteins are divided into two categories, and one is these are the innate cells, and then we have adaptive cells. The innate cells are like our natural killer cells, our macrophages, and our adaptive cells are like T cells, B cells that respond to these things. So it's the cell response, it's the immune response, and it's gene regulation. So of these, we have ERAs, estrogen receptor A's, and ERBs, estrogen receptor B's. These are inside each of the cell, and they control what genes get turned on and off. And then we have some other proteins that are on the cell surface. They send the messages in response to estrogen, and they signal to activate other cells directly and indirectly in response to certain gene expressions. So they all work together. And so I like to draw. I don't use too many things. So threat sends a message to the natural killer cells. These will then produce cytokines, sends messages also to the macrophages, which then will signal how many T cells, B cells, how many of those are produced or activated, and tells them what to do. So there's lots of signaling going on. And so when we look at, there's so many factors, and it's almost hard because I didn't organize a way to talk about this, but the estrogen in women in a study found in Frontiers Immunology 2014 with a follow-up 2018, basically it found they took estrogen from women and men, all right, and they tested it against the virus. The estrogen in women from women were able to fight off the virus. The estrogen in males were not. So we were able to determine at the time, like, there is a distinct difference between these. And so we look again, or I looked into, okay, how can I organize this into all of that? So as I show you on this little thing, we have estrogen receptors, right? And they ERAs, ERBs, they are inside the cells. They control what the genes are turned on and off. And then we have GPERs, GPR30s. They're on the surface of the cells. They're on the surface. ERAs, ERBs are inside. So we have a threat, and the estrogen receptors are signaling, right, what to do. So let's go through that. And we'll talk about cortisol in a minute, because cortisol is huge. Estrogen is, with all the estrogen receptors on each cells, and each of them responding directly and indirectly to these signals. We got NK cells. These are NK cells, natural killer cells, are important for fighting infections. They're the first ones on the line of defense that just slash and fight the infection. They also help in protecting and fighting against cancer. And then we have macrophages. There are all these little cells that help in response to the NK cells and the cytokines that are coming out. They help to balance homeostasis by reducing inflammation, to help heal injury and infection and things like that. So NK cells and macrophages work really well together to maintain that balance. Now, based on the estrogen receptors, they can be overactivated or balanced out. And then they send these signals out to the T cells and the B cells. The T cells protect and prevent infections and diseases. The B cells, they help to create the antibodies that protect against these future infections and allergies and things like that. So they're all sending signals, all these cells. But the estrogen receptors within each cell are really, really important to that. So let's go through this little newsletter I sent out. I'll just summarize it for you if you didn't read it. I got some of my notes. So the relationship with immunity is estrogen can enhance your antibody production in your B cells. So one moment. I am being interrupted. That's awesome. Sorry, guys. That's my daughter. She was letting me know she's going to her friend's house. Okay, so estrogen helps by enhancing antibody production in the B cells. It can also overactivate it, which means it becomes too active and can then polarize that inflammatory response. It can improve or even, what's the word I'm looking for? Improve or overactivate vaccine responses to vaccines. Estrogen will help you fight infections more effectively. There's over 400 very critical functions of estrogen, specifically E2 estrogen, that's critical to your brain function, your nervous system, your blood vessels, your muscles, your digestive tract, reproductive organs, your skin, your hair, and your breasts. And so without estrogen in women, a lot of cards will fall. And so when we look at these things, and how estrogen plays a critical role in all of these functions, it regulates the function of the thyroid, which we'll get to in a moment with cortisol. When you work out and when you're training, it helps reduce muscle inflammation, which helps you recover from a workout or training session much quicker. And it helps you focus and stay on point. It allows you to be able to concentrate, think at high levels, things like that. It is, in comparison to progesterone, I always compare estrogen and progesterone in women. Estrogen is similar to testosterone. So it increases your performance, it increases your alertness. But with estrogen, because the way it works with cortisol, the higher your estrogen, the higher your cortisol release. And so I've got a little thing here too. This is the difference between men and women here. Over here on the left, you'll see that this is a woman's response to a stress stimulus. On the right, over a 24-hour period. And on the right is a male response to stress stimulus. And so because of estrogen, women tend to have higher, the more estrogen you have, the higher your cortisol response is, the longer it is, and it becomes more prolonged. It's a prolonged, more chronic response. So when does our cortisol goes up, either acute or chronic? It's responding to any stimulus, any stress. Stress can be physical. That could be, injury or illness. That could be in positive ways. So working out is a great thing, but it does raise your cortisol. It could be psychic stress, mental, emotional. That's usually what people think of or refer to when you say stress. Pretty common. Nutritional stress. I spoke earlier about diet, and studies and a lot of literature out there is our standard Western diet very high in a lot of additives, um, you know, seed oils and all kinds of things, sugar, all of that increase inflammation, which in response again increases cortisol. So with women, we have a more prolonged higher impact in response to that stress, which if you're eating a poor diet, you've got inflammation, that's chronic stress. You add on top of that any physical stresses, you add on top of that mental, emotional stresses. And then we've got chemical stress. Chemical stress is any exposure environmentally to certain chemicals. That can be pharmaceutical drugs, it could be alcohol, recreational drugs, it could be adjuvants, solvents, cleaners, things like that, perfumes, all the kind of stuff we put on our face, makeup, all that. And going back to nutritional, you could say that caffeine could be one of those as well. Caffeine is certainly going to increase your cortisol, but lots of pharmaceuticals that we take can also increase cortisol. Then we've got EMF stress, so electromagnetic frequencies. It's really hard to avoid nowadays. I've got EMF bouncing off of me right now. So do you if you're watching this. And we've got thermal stress. So anything that antagonizes or challenges the body to adapt to certain thermal changes. So there's a lot of different types of stress. It's not just mental, emotional stress. And so when we're talking about physical, psychic, nutritional, chemical, EMF, and thermal stress, we got to think of all 5 of those. And if you're experiencing those on a daily basis, you most certainly have chronic stress. And if you are a woman, you most certainly have a lot more cortisol running through your body. And especially if you are on your cycle. Here, I'll show you this one. So in the red, that's our estrogen. In the blue or teal, that's progesterone, and testosterone, orange. Yes, women have testosterone. It bumps up a little bit mid-cycle around the time of ovulation. But so yes, we've all got estrogen all the time, but this is through a regular cycle. So, anywhere from 1 to 29, 30 days. Regular average cycle looks like this, no matter how long your cycle is. And you'll see that estrogen rises twice in the cycle. It's at its highest right before you ovulate, comes down, but then it bumps up again. So we look at during these 2 phases of our cycle, if we're experiencing chronic stress and we then hit mid-cycle around ovulation, we're pumping even more cortisol through the body. And again, a little bit right before our period in the luteal phase. So acute and chronic stress, most women are going to be experiencing chronic stress. So reduced estrogen, which is, anywhere between, if we're looking at like a 28-day cycle, anywhere between 1 to 7 days, that week right there, you're going to have your lowest estrogen. So when you have reduced estrogen with increased cortisol, right? So those 7 days right there, for example, with increased cortisol, chronic stress, the image on the top left, you're going to have increased inflammation. Again, because estrogen does help with the inflammation. Estrogen sends these signals to all your cells to either increase or lower your inflammation. And if you have stress and your inflammation goes up, it's depending on that cortisol. So these 7 days, for example, is very critical because you're going to have increased inflammation, more prolonged inflammation response, and a reduced thyroid or endocrine function during this time. This is why during this time in reproductive years, women are more susceptible to viral infections, bacterial infections, things like that. The immune system is at its lowest during these first 7 days on an average 28-day cycle. And so let's say we get, we're exposed to some kind of a virus during that time. NK cells are increased. They increase and they send out cytokines, which will basically are to attack. They're the army. They send out an army to attack this thing. Okay, so if we have too much production of NK cells, we can actually reduce the killing power. So it's like a power in numbers. The body has a natural way of maintaining homeostasis and balance. The NK cells, the macrophages, the B cells, the T cells, they work all together to maintain a balance, whether to activate, deactivate, turn on, produce more, reduce. And so if we have high inflammation that becomes prolonged inflammatory response due to chronic stress, and the NK cells then are increased, we can decrease their killing power, right? They got to divide. They got to divide everything amongst that. So then we've got the macrophages will become overactivated, and either A, overproduce cytokines, which can begin to attack healthy tissues, which will be very important with T cells. That can lead to autoimmune conditions. It can overactivate or then deactivate those. Those will send signals to the T cells. T cells will then increase inflammation, and ERAs will the ERAs will decide or get the signal either increase inflammation or the ERBs to reduce inflammation. And this balance is influenced by macrophage activity and or polarization. So the B cells, stay with me here. B cells will then say that's by the time you get to the T cells, you're sick, you got a viral infection, but you're getting through it, right? You got a cold, something, whatever it is. So you rest, you take care of yourself. So now you've got all of these T cells, they're reproducing white blood cells, they're helping you fight this infection, you're getting better. The B cells are then signaled to increase antibodies. And this is towards any sort of histamine infection, allergies. And they recognize these antibodies and they neutralize those threats through sort of this inflammation memory bank, if you will. It's like, so now we've had this virus, we're getting through it, you're getting better, we're over it. The B cells then will program the sequence of what it was that caused this inflammation. And it's like, now remember this. It's like PTSD within the cells. It's like, all right, we now came in, we recognize this protein, and we're going to attack it. So why is that important? Because these sequences, these proteins that carry all these sequences in the cells that have this memory, right? Something comes into the cell, and if it looks like or mimics the sequence that is already stored in there, it's going to attack it and or then go back up the chain and start overproducing, overactivating all of your cells. I'm trying to put this as simply as possible, and if you have questions, of course, you can always go to BodhiBuilding and ask all the questions there. Jen is not here, so she's not going to be modifying any of the questions that may be going on. But hopefully everything's okay in Panama. Hope everybody's okay with the earthquake. So let's say all the ingredients of that protein that designed the sequence, right, that now sits in the memory banks of what to attack, right? You're now immune to the thing. So going back to how 85% of women represent autoimmune diagnoses, and all the 400 plus functions of estrogen and what it does in the body, and the estrogen receptors and how they directly influence the signaling between cells and what to do in response to the immune system. We look at, let's just say let's look at vaccines, for example. And you've got all these adjuvants and you've got these solvents that go into the vaccine, maybe mRNA, or it's a live virus vaccine. And it can cause, basically through the estrogen receptors. Again, if you look at the bottom, I can't do this backwards. There we go. The bottom image, then you see that your estrogen at its peak, and then there's another area there where it rises again before menstruation. Those times in your cycle is when you're going to have more responses to the more immune responses within the cells due to the higher levels of estrogen and how they talk to the cells. And so, let's say if you get an mRNA vaccine or a live virus vaccine, and you've not, let's say scenario one, you've never had the virus before. You get the vaccine. Now it's stored in the memory, and then the virus comes in again. It mimics the same thing, right? So then the NK cells will then send in cytokines, and it increases in numbers. Then the killing power is then reduced. The macrophages become overactivated. Next thing you know, they're attacking healthy tissues. Scenario B could be also, again, these are still studies that are looking at this, is that you've had the virus, you've been exposed to something, then you get the vaccine for it, which is composed of proteins that are delivering a similar sequence along that line of what it is. And your body recognizes it right away, right? But it's not really what you're immune to. So there's a lot of mixed signaling going on that can, once again, it can polarize the inflammatory response. And that's why a lot of times when people get a vaccine, they get sick, right? So if you get the flu vaccine and then you feel like you have the flu for a while, and you go back to the hygiene hypothesis of where our immune system overreacts to otherwise somewhat harmless substances or pathogens or bacteria, because we are not allowing the immune system to be exposed to these things. And so we're not allowing the amazing intelligence that the body has to create a homeostasis and a balance of between estrogen receptor A's that increase inflammation and estrogen receptor B's that help decrease that inflammation. There's a lot of interference happening there that is overpowering the certain communication and signal sequences that and protein sequences that are being read. And so when we look at different parts of the immune system or different parts of the woman's cycle when estrogen is high, we don't know a lot about what, if you are going to get a vaccine, should you get it when estrogen is low? Should you get it when it's high? And are we looking at things like dose dependent, right? We're giving boys and girls, men and women, all the same doses of certain things, any sort of immunotherapy or vaccines and things like that. Are we making considerations to the dose dependency in the cells that is required in women, because we have these estrogen receptors that directly speak in between cells and signal them in response to immune system pathways. So that's something really important to look at as well. And there are three of that I know of studies that are ongoing right now, and you can find those at Frontiers of Immunology. They're looking at these. They're ongoing studies currently. But that doesn't negate the fact that women, again, top left image, is that do have higher levels of cortisol due to estrogen. So you're looking at the bottom left image, mid-cycle, and sort of in the beginning of the luteal phase and middle of the luteal phase, we have higher levels of estrogen. We are naturally, without any other stress, we are naturally then going to have higher levels of cortisol. The good thing about the luteal phase, when the estrogen goes up, those higher levels of cortisol are then counterbalanced by higher levels of progesterone. It helps to counterbalance the inflammatory effects of cortisol. However, mid-cycle, the cortisol is at its peak, and generally, unless you have low estrogen, your estrogen ratio, progesterone's a little bit lower. So you're going to have peak cortisol going on here. So if you've got acute chronic stress going on, physical stress, you're working out every day, you have an injury, or you're recovering from a surgery, or you just got over the flu, or you have the flu, and you got mental, emotional things going on, trying work-life balance and things at work, and managing all the life stresses and relationships and things like that. That's big psychic load in terms of stress. You're not eating right. Either you're not eating enough, you're eating too much of the wrong things. That's going to increase inflammation. It's going to increase your cortisol. And then you're exposed to all these things, like, all these chemicals in your makeup and your face stuff and your cleaning products and your detergents and medications and pharmaceuticals. That's gonna increase the load. Electromagnetic and thermal, like all of those are going to increase your cortisol on top of already having a base level higher cortisol that creates a chronic inflammatory response. That just in itself, in my opinion, the way estrogen works with cortisol, it could be a huge, huge reason, again, studies are showing it, as to why women are more prone to autoimmune diseases. Because again, it can cause the immune system to overreact and over-respond and begin attacking healthy tissues. Take this one down. So here's just the macrophages. These are, that's not very big, but basically all of these are different. Let me edit this so you can see it. Full screen. Here we go. These are all the functions of macrophages, right? So supports tumor growth, metastasis. So if you've got overactivated macrophages, you're going to have a faster rate of tumor growth. And then we look at, it helps lipid uptake, fat storage, got the CNS neuroinflammation. Yes, it's very important for neuroinflammation, helps with the brain functions and reducing inflammation in the brain. Liver, it helps to clear pathogens and endotoxins. Again, you go back to the chemical stress. Your liver is responsible for clearing toxins. It's the filter of your entire body. And you've got these estrogen receptors on every liver macrophage. And one of the most common autoimmune diseases diagnosed in younger women especially, but women overall, is type 2 autoimmune hepatitis of the liver, when the cells within the liver begin attacking the liver. That also then can affect iron recycling and all of that. And we've got wound healing. We talked about that. Muscle tissue damage. It helps to reduce inflammation, to help healing. Macrophages are really responsible also for bone remodeling and all of that. Maintains calcium. And there's some other ones in here. Clearing pathogens and debris in the lungs, remove excess RBCs, red blood cells, iron recycling again, and maintain immune homeostasis again. It's protecting against infection in the abdominal cavity. We've got fetal development and maternal fetal tolerance, et cetera, and so forth. Let me unview that one, because I had another one in here I wanted to show. Here we go. It's not very big. See if I can make it bigger. Full screen. So this is how estrogen, again, the responses into each cell, pro-inflammatory, anti-inflammatory condition, right? So it's literally speaking to every cell. You've got NK cells, B cells, T cells, macrophages once again. And so without estrogen, we don't have this signaling happening as you see here in this image. It's telling your body constantly, all the time, what to do in the cell in response to inflammation. So anti-inflammatory, you got cancer or autoimmunity. It's telling every single cell how to respond. Now, if we are looking at that in a macro view, like a big picture, one may say, well, we need to focus on the cortisol and the stress response. Yes, because even without all of these estrogen receptors and these ER proteins that are communicating and sending signals within each of the immune cells, without that, we are still living in a very high chronic stress modern time. And with women having more estrogen, which leads to higher cortisol, the majority of women have chronic stress issues that are affecting their bodies. That's going to cause problems in itself. But how it affects our immune systems is that it becomes a chronic pro-inflammatory, prolonged response. And cells become overactivated, overburdened, overproduced, which then reduces the killing power, and they begin to then polarize against the body's own healthy tissues. So what do we do about it? 85% of women account for, or 85% of autoimmune conditions are women. Women account for 85%. And we have estrogen. It's an amazing thing to have. And so what can we do to mitigate this for women, females who have higher levels of estrogen, especially reproductive years, and especially within those reproductive years, specific times throughout the cycle? And so estrogen is an amazing thing. It has amazing functions. It promotes your metabolic system, makes it faster, more efficient. It does all these things. You're going to have better digestion, right? Ever notice if you're in reproductive age during days 1 through 7, they call them the period poops? Directly and indirectly related to the levels of estrogen in your body during those days. Then your estrogen levels start to rise right around here, and digestive tract is starting to normalize. You're like, great, feeling much better, right? You don't have to worry about taking a heavy squat during those days. Joke, but not joke. It's a very real thing. It happens. But your GI tract is really important. Your endocrine system, your thyroid, all of that, your skin and your hair. Estrogen has direct and indirect impacts on the cells that account for your skin and your hair. So you look at, again, the most common autoimmune conditions in women, alopecia and psoriasis. Those affect the skin and the hair. Alopecia is the hair, psoriasis on the skin. And then how the liver and the thyroid are directly interrelated. And we look at type 2 autoimmune hepatitis of the liver, and all of the Graves, Hashimoto's, all of those autoimmune thyroid conditions that are very commonly diagnosed in women. Type 1 diabetes is very common in women, and estrogen directly affects the insulin. And so the higher your estrogen is, the more power it gives insulin to decrease glucose. So when you have lower estrogen, insulin is not as powerful in reducing the glucose in the body. And so again, type 1 diabetes, we've got anemia. We are talking about iron recycling there in the macrophages. So if that's being overactivated or polarized, then we cannot efficiently recycle iron in the body. So now we've got an autoimmune condition in women that's very common, hemolytic anemia. Irritable bowel disease, again, yes, improving diet and reducing your nutritional stress was going to reduce your inflammation. But that may not be all you can do now at this point. If you've been eating poor or for the majority of your life, like me, ate a pretty crappy diet. 21 years old, I was diagnosed with celiac disease. And so when you look at also different vaccines that insert these proteins that have a sequence and a signal, we also look at the adjuvants and the solvents that are a part of this vaccine that become a part of that sequence. So you can, do your own side look up. Children's Health Defense has great information on that. Why did peanut allergies explode, after the 90s, 1990s? You look at a couple of those vaccines that were added onto the schedule had peanut oil in them, right? So you're creating this, inoculation for. A vaccine is an immunotherapeutic product, but it's a liquid, and you're creating this vaccine, and in it has the mRNA or the proteins, the virus, whatever it is, but it comes with solvents and adjuvants in order to get it into the tissues. Those become part of the sequence that then signal, and part of the protein sequence that signal to all of your cells what is the threat. And if peanut oil is in there, now we have a bunch of peanut allergies. Now, there's a lot of studies, there's a lot of literature. I encourage you to go look into that. That's just one example. And so what else, we got to look in what else is in these vaccines and weigh risks and benefits. Doesn't mean you shouldn't or don't get the vaccines. It's you should look for females, especially should look at everything going into them and then weigh that with your acute and chronic stress that you're dealing with, weigh that with your reproductive health, weigh that with your hormone health and the levels of hormones that you have, your age, all of that, physical, psychic, nutritional, chemical, EMF, thermal stresses that you're dealing that will impact how your body is going to respond to that. And if you're already dealing with hormone issues or reproductive issues, any sort of vaccine that also carries certain, what do you call it, like cell lines from, monkey or aborted fetal cell lines, certain pancreas, ovarian cell lines from certain aborted fetal cells or monkeys. I think they have cows and some. Look at that and see, like, if you have certain issues going on right now, that may not be the thing to do. It also could be the precursor to what you're experiencing now, and to be very, very careful about those things. So what can you do? Take care of what you're eating. Be sure that you're eating as close to a holistic, paleo-ish type of diet. Make sure you're eating more things that have, that you can get on the parameter of the grocery store. More vegetables, more fiber is really good for you. And you're taking care of your gut health, and you're taking care of your overall health in a very holistic way. Nutritionally, you don't want to get the majority of your things, your groceries, from the middle of the grocery store. The more ingredients in something, probably the worse off it is for you. Reduce your nutritional stress 100%. eat more holistically, more whole foods, pasture raised, wild caught, all the things. It's not just a hippy dippy woo woo thing. It's very real. It's very real. You look at the differences between our ingredients in the USA and ingredients in Europe. I mean, you know what? I even have pictures because I talked about that today earlier. Just an example, the USA version versus the UK version of ingredients. So we have to ask ourselves if we spend more on healthcare and we have some of the sickest people, we score the lowest worldwide, one of the lowest worldwide in health. And then you look at our ingredients, like just think about something like that. The fewer ingredients, the better. There is work being done on that as we speak, which is great. Yeah, reduce your chemical stress. That's another easy one. You know, look at your cleaners, your detergents. Stop wearing perfume. You save a bunch of money anyway. Burning candles and air fresheners, all that stuff can be extremely toxic, and it's an endotoxin. The liver has to process it. A lot of them are antagonize and do disrupt the endocrine system, do disrupt your hormone balance, and will create an imbalance in your hormones, which you don't want to do, because you do want your estrogen. When you got your estrogen, you're primed, and you want to maintain normal, good levels of estrogen overall. And again, when you can, reduce your exposure to electromagnetic frequencies. Put your phone down. Get away from the screens. Get outside for as much time as you can each day. Get some fresh air. Get some natural sunlight. And yeah, physical stress. If you're overtraining, cut it back. If you're not moving enough, that is also physical stress. If you're injured, if you're menstruating, allow yourself time to relax, to heal, to repair, and do what the body needs it to do. And again, I'm going to leave it at that. We always go much deeper, and any questions and things like that, go to BodhiBuildingInstitute.com or members.BodhiBuildingInstitute.com. You can sign up for a free membership. You can ask all the questions in there to your heart's desire. You can also sign up for a mastery membership. We have office hours every Monday for 2 hours. We do peer reviews, Q&As, all of that. So look forward to seeing you all there, and send me your questions if you got them.